shop owner has bought in the Santa or in any Raitu Bazaar.
एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types:
up, down, right, left.
I am not inferior to anyone.
We are Clarus. We are top on the Everest. Congratulations.
I want to be a leader.
Hi friends, this is TSWREI from Kanjara, Nizamabad. So friends, first look, observe me. Friends, what I did is I had clapped my hands. So friends, again what I did is I tapped the table with my hand. So friends, in both cases what you observed is you heard some sound. So today we are going to discuss about the topic sound. So friends, let's see on the screen. Here the boy was making some sound. And friends, do you know what is the meaning of sound? Sound is a form of energy which makes us to hear, and it's produced by the vibrating bodies and transmitted through a medium and received by our ears. So friends, the meaning of sound is it is a form of energy. Are you understand friends? Yes. Here I would like to tell about a wave. Do you know about a wave? What is the meaning of a wave? Wave is a vibratory disturbance in the medium which carries energy from one point to another point without direct contact between 2 points. And this wave was produced by the vibrations of a particles through which it passes. When this wave was passes through a medium, the medium itself does not move from along the direction of the wave. Only the particles can vibrate along the direction of the wave. Friends, for example, when sound waves produced by the ringing bell can comes to hear us at the through air, but it is not the actual movement of a air. Only the sound energy can travel through a medium by the vibration of a air molecules. Friends, do you know how many types of sound waves? Yes, there are 2 types of sound waves. Do you know what are there? There are longitudinal waves and transversal waves. So friends, here there are 2 types of sound waves, transversal waves and longitudinal waves. So friends, first let's discuss about the longitudinal waves. If the particles of a medium vibrate along the direction of the wave is known as longitudinal waves. If the particles of a medium vibrate along the direction of the wave is known as longitudinal waves. So friends, let's see on the screen. So friends, here longitudinal waves means if the particles of a medium vibrate along the direction of the wave is known as longitudinal waves. So friends, do you know what is the meaning of transversal waves? If the particles of a medium vibrate perpendicular to the direction of the wave is known as transversal waves. If the particles of a medium vibrate perpendicular to the direction of the wave is known as transversal waves. For example, water waves. So friends, let's see on the screen what is the meaning of transversal waves. Transversal waves. If the particles of a medium vibrate perpendicular to the direction of the wave is known as transversal waves. So friends, I am repeating again, the particles of a medium vibrate perpendicular to the direction of the wave is known as transversal waves. And for example, water waves. So friends, here the wave, we already learned that wave is a vibratory disturbance in a medium. Here we are observing blue particles, they are not moving, but there is a disturbance in the medium. So friends, we can say that these water waves is for example for transversal waves. Friends, here do you know and or you understand what is mean by transversal waves and what is mean by longitudinal waves? These longitudinal waves involves in the change of density of a medium, wherever transversal waves is involves to change the shape of the medium. Friends, do you know what is mean by crust, throw, compressions and rarefactions? Let us learn about it now. So friends, look at on the screen. Crest. The highest part of a wave is known as crest. So friends, the highest part of a wave is known as crest and trough. The lowest points of a wave is known as trough. So friends, here we are observing one picture. So the highest part of a wave is known as crest and the lowest part of a wave is known as trough. Are you observed friends? In this figure, we are seeing the highest part of a wave is known as crest and the lowest parts of a wave is known as trough. So friends, let us learn about what is mean by compressions and rarefactions. So friends, look at on the screen. The closer together part of a wave is known as compressions. So friends, are you understand? The closer particles of a wave is known as compressions and the spread out particles are known as rarefactions. So friends, let us see on the screen. The closer particles together of a wave is known as compressions and the spread out particles of a wave is known as rarefactions. So friends, in this figure, in this wave, here we are observing some closed particles. So these closed particles are known as compressions and we are also observing spread out particles. These spread out particles are known as rarefactions. So friends, let us learn about the characteristics of a sound wave. Do you know what are the characteristics of a sound wave? Let us discuss with me. So friends, this sound wave is classified completely with 5 characteristics. Friends, do you know what are there? They are amplitude, wavelength, time period, frequency and velocity. So friends, first let us learn about the wavelength. Wavelength means the distance between two consecutive compressions or two consecutive rarefactions is known as wavelength. So friends, the distance between two consecutive compressions or two consecutive rarefactions is known as its wavelength. So friends, in other words, we can say that the distance between two consecutive crest or two consecutive throw is known as its wavelength. So friends, let us see on the screen. So friends, here we are already observing that in first figure we are observing the closer particles known as compressions and the spread out particles are known as rarefactions. And also in second figure we are observing that the upper part of a wave is known as crest and the lower part of a wave is known as trough. And friends, and the characteristics of a sound wave. So first about wavelength. The distance between two consecutive compressions or two consecutive rarefactions is known as its wavelength. And friends, do you know what is the SI unit of a wavelength? The SI unit of a wavelength is meters. And friends, it is represented by the lambda and this lambda is came from Greek word. So friends, you know what it is represented by the lambda. So which is represented by the lambda? Yes, the wavelength is represented by the lambda. So friends, in this on the screen we can see the symbol of a lambda. It is as a cross Y. Are you observed friends? It is as a cross Y. And friends, the second characteristic of a sound wave is amplitude. So friends, the amplitude is the magnitude of a maximum disturbance in the medium or either one side of a mean value is known as amplitude. So friends, the magnitude of a maximum disturbance in the medium or either one side of a mean value is known as its amplitude, and it is usually represented by the letter A. Friends, do you know its SI unit? The SI unit to measure the amplitude is meters, though it is also measured in centimeter. So friends, let us see on the screen. So amplitude, the magnitude of the maximum disturbance in the medium on either side of a mean value is known as its amplitude. Friends, the magnitude of the maximum disturbance in the medium or on the either side of a mean value is known as its amplitude, and it is measured in meters. So friends, the third characteristics of a sound wave is time period. Do you know about time period? The time taken between two consecutive compressions or two consecutive rarefactions to cross a fixed point is known as its time period of a wave. In other words, we can say that the time taken between two consecutive crests or two consecutive throws is known as its time period. So friends, let us see on the screen. Time period. The time taken by two consecutive compressions or two consecutive rate fractions to cross a fixed point is known as its time period. And friends, do you know the SI unit of this time period? The SI unit of this time period is second. For example, friends, a violin and flute is both played in both at the same time. These both sounds are carried at the same medium, that is air, and they travel at the same speed, but we require the ears with different sound. Friends, do you know why it is happened? Because it is due to the different characteristics associated with the sound. So friends, let us learn about frequency. This frequency tells us how frequently an event occurs, and for suppose you are beating a drum, how many times you beat a drum per unit time is the frequency of you are beating a drum. Friends, that frequency can tell us how frequently you are beating a drum if you are beating a drum. And friends, the change of density from maximum value to minimum value and again maximum value makes one oscillations. So the number of such oscillations is known as the frequency of a sound wave. So friends, if you count number of such or compressions or rarefactions, we will find the frequency of a sound wave. Here this frequency is measured in hertz. Friends, I would like to tell about a great scientist named Hertz. The full name of Hertz is Heinrich Rudolf Hertz, and he was born on 22nd February 1857 at Hamburg. He confirmed MX well. So friends, let us see on the screen. So friends, his full name is Heinrich Rudolf Hertz, was born on 22nd February 1857 in Hamburg. He confirmed J.C. Maxwell's electromagnetic theory by his experiments. He laid the foundation for future development of radio, telephone, telegraph and even television. So friends, the SI unit of this frequency was named as Hertz in his honor. Are you know about in his figure he is a Hertz. And friends, let's learn about frequency range of a hearing human ear. Friends, do you know the audible range of a human ear? You might get that. What is meant by audible range? So friends, the sound which we are able to hear is known as audible sound, and the audible range of a human ear is 20 Hz to 20,000 Hz. So friends, are you know what the audible range of a human ear now? Yes, the audible range of a human ear is 20 Hz to 20,000 Hz. Friends, I would like to give more information about this. The sound which is less than 20 Hz is known as infrasonic sound. So friends, which is less than our human range, human normal range is known as infrasonic sound. And friends, so friends, look at on the screen, the range of frequency from 20 Hz to 20,000 Hz is known as the frequency range of hearing of humans. This is the audible range of sound frequency. And infrasonic sound, sound which frequency below the normal range of sound hearing is known as infrasonic sound. It is in the sound of 20 to 200 Hz. And friends, do you know fifth characteristics of a sound wave? It is a speed. So friend, that do you know about speed? It is also known as in our day-to-day life as velocity. So the time. So friends, let's see on the screen. So the distance travelled by a wave in 1 second is the velocity of a wave. Friends, are you understand what is meant by wave velocity? The distance travelled by a wave in 1 second is called velocity of a wave. It is measured in meters per second. So friends, the equation for wave velocity is frequency into wave velocity. Friends, here I would like to tell about sound speed at these different types of mediums. So friends, let's see on the screen. So friends, here we are seeing different types of mediums and its speed of velocity. Here in air of 20 Celsius, the velocity of a sound is 343 meters per second, and at air 0 centigrade 331 meters per second, and at water 25 Celsius the velocity of a sound is 1493, and at sea water the velocity of a sound is 1533, and at the diamond 12,000, and iron at the velocity of a sound is 5130 meters per second, and at the copper 3560, and at last glass is the velocity of a sound is 5640. So friends, are you know what is the velocity of a sound in different types of mediums? So friends, here I would like to tell a sample problem. So friends, the question is, look at on the screen. Here we are observing one question. So sound waves travels with the speed of about 330 meters per second. What is the velocity of a sound whose frequency is 550 Hz? So friends, I am repeating the question once again. Sound waves travels with the speed of about 350 meters per second. What is the wavelength of sound whose frequency is 550 Hz? So friends, here they are given that speed of a waves and the frequency of a waves. So here the speed of a wave is 330 meters per second and the frequency of a wave is 550 Hz. We have to find the wavelength. Here we are observing one equation, that velocity is equals to lambda into frequency. Here lambda represents wavelength. So friends, 350 is equal, by applying these values in the given equations, we will get 330 is equals to 550 into lambda. By transposing 350 into RHS, we will get lambda is equals to 330 by 550. By by cancelling them, we will get the answer 0.6 meters. Friends, here I would like to give one homework for you. So friends, look at on the screen. Here your homework is, what is the frequency of a sound wave whose time period is 0.05 seconds. So friends, I am repeating the question once again. What is the frequency of a sound wave whose time period is 0.05 seconds? And I want to give one hint for you, that frequency is equals to 1 by T. Are you understanding, friends, what is your homework? And friends, I hope you will give the answer for this question in our questioning hour. And friends, let us learn about infrasonic sound. So friends, this infrasonic sound is a slow frequency of a sound. It is not heard by the human beings. And friends, but earthquakes and other animals like whales, elephants, rhinoceros can hear this infrasonic sound. Friends, now we know what is mean by audible sound and infrasonic sound. So do you know about what is ultrasound? Let me tell about it. The sound which is higher than the 20,000 Hz is known as ultrasound. This is also known as ultrasonic sound. So friends, do you know what is mean by ultrasound? The sound which is higher than the 20,000 Hz is known as its ultrasound. So friends, it is not heard by the human beings, but dogs can hear this ultrasound up to 50,000 Hz. Friends, are you know this? These dogs can hear that these ultrasounds up to 50,000 Hz. Friends, this is the reason why the police can use the dog as a detective works. Friends, and other animals like bats, leopards, etc. can also make the ultrasonic sounds. Friends, do you know? Also these bats can produce ultrasonic sounds up to 1,20,000 Hz. Are you hear this at anywhere? No. So friends, also children under the age of 5 years can also hear this ultrasonic sound up to 25,000 Hz. Friends, so look at on the screen. Ultrasound waves is frequency above the normal range of a hearing. And friends, are you understand? Sound waves with frequency above the normal human range of hearing is known as ultrasound. Friends, do you know this ultrasound is also used in our day-to-day life in many ways. But we are going to discuss about only industrial applications and medical applications. So friends, do you know how we use these ultrasonic sounds in our industries? Let's discuss about it. It is used in industrial as for drilling holes and making cuts of desired shape. So holes can also drilled up by making vibrations of ultrasound in metallic rod known as horn. And friends, do you understand? The holes can also drilled up by using ultrasonic vibrations in. Hello Swara.
Hello.
May I know about you?
Yes, I am from Nallavagu.
Okay, Swara, what is your doubt?
Atom, how you represented to atom?
Atom. It is not our topic, friend. Hello. Okay friends, let's continue our class. So friends, these holes can also drilled up by using this ultrasonic sounds in metallic rod. So these holes also known as horn. The shape of this horn is as same as tip of a horn. Friends, and these act like a hammer. Hammering the plate can produce 100 times per second. Friends, it is also used as ultrasound cleaning. Friends, we normally clean dirty cloths, plates and large objects by dipping them in detergent solution and then rubbing and washing. Yes or no friends? Yes. So, the hard to reach particles cannot clean easily by this method. So, ultrasonic waves can use it to clean such metals by which are placed in cleaned method. And friends, the ultrasonic cutting and drilling are very effective for fragile materials like glass, for which ordinary methods might not succeed. So, friends, it is also used at ultrasonic detection for defects in metals. Friends, metallic components are used in buildings, bridges, scientific equipments and so on. Yes or friends? Yes. So, if there are cracks or holes inside the metal used, what we have did? It is not visible by outside. So, we will use these ultrasonic vibrations to detect such defects. So, friends, let us see on the screen the applications of ultrasound. Hello, Swara.
Hello?
Hello, Swara. What is your doubt? Hello.
Hello, I am from Nallavagu.
Okay, Swara. What is yours?
My question is, what is speed of sound wave?
So, what is your doubt, friend?
What?
Please, it is not audible to me. Can you repeat it?
What is speed of sound wave?
Okay, Swaro. It's not audible to me. Can you repeat it, please?
What is speed of sound wave?
Sound wave. What is meant by sound wave?
Yes.
So, friends, sound wave is a vibratory disturbance in the medium. Friends, it is also we are learnt what the applications of ultrasonic waves in industries. So, let us see on the screen. So, friends, it is also used in applications of industries, as ultrasound are used to detect the presence of flaws or defects in the form of cracks, blowholes, porosity, etc. in the internal structure of a metal. Yes or no, friends? Yes. And also used as ultrasound is used in industry to clean hard to reach particles of of objects such as spiral tubes, odd shaped machines and electronic components, etc. And so, friends, let us discuss about medical applications of these ultrasound waves. So, friends, do you know how we use it? Let us discuss about. These ultrasound waves are used to detect, to investigate the internal organs of a human body such as liver, kidneys, hearts, etc. So, it is also used as it is also can penetrate the human body and it can reflect on the ultrasound in different ways. So, friends, due to this reason, ultrasound is being increasingly used in medical and surgical diagnosis in hospitals. So, friends, these ultrasound waves are used to investigate the organs which are inside the human body by obtaining the pictures of internal organs. Friends, the technique of obtaining pictures of internal organs of a human body using ultrasonic waves is known as ultrasonography. Are you understand, friends? The techniques of using ultrasound waves to obtain the picture of internal organs is known as ultrasonography, and the use of ultrasound waves to investigate the action of a human heart is known as echocardiography. And friends, it is also used to break the kidney stones of a patient which are very painful. So, friends, sometimes we observe some tiny particles in the kidneys which are very painful. So, when high frequency of sound vibrations, ultrasonic vibrations directed on the kidneys of a stones, the strong vibrations of a ultrasonic waves can can break the stones into fine particles and the patients can get relief. Friends, it is also used to scan a developing fetus on the monitor. Friends, do you know what is the meaning of fetus? It is a unborn baby. So friends, let's learn about these applications of medical applications on the screen. So friends, let's see on the screen. Applications of ultrasound in medical. Ultrasound scans are used to monitor the development of fetus inside the mother uterus. Friends, we already learned that what is the meaning of fetus. Do you know what is the meaning of fetus? It's unborn baby, and it is also used to investigate the internal organs of a human body such as liver, gallbladder, pancreas, kidneys, uterus and heart, etc. And it is used to break kidney stones into fine grains which then get flushed out with urine. And friends, and it is also used as in sonar apparatus to measure the depth of sea or ocean and to locate undersea objects like the shoal of fish, submarines, sea rocks and hidden eye breaks in the sea. And friends, the other ultrasound treatments are on the screen. Treating benign and malignant tumors and other disorders by a process known as focused ultrasound surgery, FUS. And ultrasound sources may be used to clean teeth in dental hygienic. Okay friends? Yes. And focused ultrasound sources may be used for cataract treatment. And friends, the low intensity pulsed ultrasound is used for therapeutic tooth and bone regeneration as a guidance tool for keyhole surgery. Detecting prostate cancer early. And friends, it is also used in sonar. Do you know what is the meaning of sonar? Sound navigation and running. So friends, it is a picture of 3D ultrasound of a developing baby. Recent advances in electronics and computing power have led to the development of 3D scanning which shows greater detail such as perspective. So friends, we have learned that what is sound, what is mean by sound wave, and how many types of sounds, what are the characteristics of a sound wave. Are you understand all these friends? I hope you are understand very well. Friends, and also we have learned that what are the applications of ultrasound in industries as well as medical. Friends, and also we have learned that what is the frequency range of a human ear and what is meant by infrasound and what is meant by ultrasound and what is meant by audible range. So friends, thank you for this. I owe my heartful thanks to our beloved Secretary Sir R.S. Praveen Kumar Sir Garu. Under the dynamic guidance of our Secretary Sir, we are practicing various activities to achieve all round development. Thank you sir. And I would like to express my thanks to Regional Coordinator Jasainath Sir Garu as well as our beloved Principal Madam Srimati C. Sindhu Madam Garu for all their encouragement and for helping us. And I would like to thank my mentor teachers Sheila Rani Madam Garu as well as Swapna Madam Garu for their encouragement and motivation. All the teachers, I would like to thank all the teachers and upload my thanks for their efforts for successing this super student program. I would like to thank one and all for their all support. So thank you one and all.